And that certainly would have saved fuel. But since this is a tutorial, I'm not trying to do everything perfectly, rather trying to explain stuff. The other thing, you can see we still have 100 seconds left here. So actually, I'm going to just speed up. Let's finish that maneuver, and then I'll show you some other stuff while we're doing that. Okay, there we go. It's not going to take much burn to do this. See, if you time this well, you can almost perfectly circulate your orbit, especially if you don't overshoot like I just did. This thing's a little overpowered, as usual. I'm building them overpowered. And like I said, the nice thing about this is I don't actually need to look at my map. I can circularize my orbit right here. Yay, mech gem. Okay, so there we go. Perfectly circular orbit for now. Should have about the same orbital period. You can see 1.976 kiloseconds versus 1.975 kiloseconds. So we're basically matching each other's speed around around Kerbal, and that's good because we're really close to each other. We don't want a big difference right now. We're not trying to catch up very much. In fact, we're going to try to slow down a little bit, but let's first fix the inclination problem. So let me show you how to do that. Now, last time I was pointing over here and you guys couldn't see it. I was talking about what these various buttons do. So let me explain them. Now, I'll explain them again quickly. So you can see right now our spacecraft is pointed in the prograde direction, which is the same as this little circle on the nav ball. And that means the nose of our spacecraft is pointed in the direction of our velocity vector. If I were to turn on my thrusters now, I would speed up. And if I go over here and I click in the retrograde direction, you'll see that my nose of the spacecraft is pointed exactly opposite the direction I'm traveling. If I were to turn on my thrusters now, I would slow down. Now, those are those two obvious ones. I suspect anybody who's made it this far in any of these tutorials understands what those things do. But what about these? Well, normal plus, I talked about last time. Normal plus, you can see, is 90 degrees off the direction I'm traveling. I'm traveling this direction, looking at the spacecraft, and it's pointed to the left of me in this reference frame. It's pointed towards the North Pole of Kerbal, in fact. So what would this do? Well, if we go over to this map here, right now, looking straight down, the spacecraft is pointed this direction. Which means if I burn in this direction, I'm going to turn this velocity vector upwards, which is going to incline the orbit in this direction. So I'm going to take an orbit that right now is equatorial, and I'm going to start slanting it this way. And the longer I burn, the more it'll slant. So that's what that 90 degree burn vector will do. If I go the other direction, normal minus, it does exactly the same thing. Now my velocity vector is still in this direction. I'm 90 degrees off in that way. So if we go over here, I'm pointed towards the South Pole. If I burn my engines now, I'm going to change my inclination so it starts looking like this. Rather than being equatorial, it's going to shift downwards as I'm flying along. So that's how you change your inclination. As you can see, we're going to want to do that. We're going to want to change our inclination. So we're going to do that. But before we get there, let's talk about these other ones. Radial plus points outwards. Now right now, remember I mentioned this blue dot on the nav ball. That is the direction pointing exactly away from the object you're oriented from, in this case, the planet. And right now that is exactly equal to radial plus. It doesn't have to be. If I'm in an elliptical orbit, they won't be the same, but right now they are the same. The reason is radial plus is the 90 degree angle. Again, let me get it perfect here. Right now I am traveling in this direction, and if I push radial plus, you'll see that the spacecraft rotates 90 degrees to that direction, pointing outwards. So it is 90 degree perpendicular angle outwards from my velocity vector in the orbit I'm traveling in. Because this is a perfectly circular orbit, or damn close, that points basically to the exact center of Kerbal. But if this was an elliptical orbit, those 2 points would not match. So you can use radial plus. Radial plus and radial minus are probably the least important of these two buttons to understand. normal plus and normal minus shifts your inclination. Radial plus and radial minus can be used to shift your orbit the same way a prograde and retrograde bird can. They're useful in certain situations. I'm not going to get into it now. Last bit are these buttons. These showed up now because we have a target, and these will basically point our spacecraft relative to the target that we're interested in. I'll talk about these more later, and this functionality will be replicated in version 0.18 with other markings on the nav ball. Basically, you'll be able to click on a target that is the thing you're trying to dock with, and down here you'll be able to click and it'll be target, and then the indicators on the nav ball will be equivalent to these relative velocities and these target and these parallel markers. Okay, so enough of that. I think hopefully that has explained some of the stuff I was trying to talk about in the last tutorial a little better. We're coming up on this point here, so we're gonna want to change our equatorial orbit to an orbit that matches this this thing we're trying to dock with. And so what we need to do is you can see we're traveling in this direction. We're going to want to move our orbit up into this plane, so we're going to want to do a radial plus burn. But we're going to want to do a radial plus burn at the right time. If we did it now, our orbit would look like this, which is not matching what we want. So we want to make that burn where these two lines intersect right here. That's called the ascending node or the descending node. So you can see right here, over here on the rendezvous module, it tells me that the time to the descending node, this is the descending node because I'm going from above to below the orbit that I'm interested in, is 166 seconds. So I will make this crossing in 166 seconds. Well, now 160 seconds. And at that point, I'm going to want to burn in the radial plus direction, and I'm going to want to move my inclination from pretty much an equatorial orbit to this 19.3 degree orbit that the other spacecraft's in. So I'm going to speed up time a little bit, and when this is about 10 to 20 seconds before that point, we're going to make our burn. So whoops, I'm looking at this one. There we go. So let's do it now. So we're going to start our burn, and you're going to see this line start creeping up. I clicked on the wrong thing. Normal plus. I don't know why I hit radial plus. I was burning outwards. The reason I noticed that was this line wasn't changing. We'll correct for that after this burn. Sorry about that. Part of this is knowing when you screw up. Alright, so you can see now I burned a little late, unfortunately, because of that mess up. So we're going to have to do another correction. But we can get most of it taken care of in this burn. That's probably enough for now. We're going to have to do another correction burn. And my orbit isn't that messed up, so we can still live with this. My orbital, maybe not. Let's go a retrograde burn. Let's do a radial minus burn and bring that apoapsis back down a little bit. Better. Okay. So we're going to need to wait to make one more burn to get these two spacecraft. Still got fuel to get these two spacecraft aligned. So we're going to wait for this node over here, which is the ascending node. So let's move around the Earth. Let's move around Kerbal. So make sure you click on the right things. Make sure you're pointed in the right direction before you burn. That is a pretty newbie mistake I write. It's better to check before you light off your engines than not check. Alright, we got 120 seconds. There we go. 20 seconds. So not a radial burn, a normal burn. And which way do we want to burn? Well, we want to move our orbit down. So we want a normal minus.